Hey guys, it's Mr. Sheeling here. This is going to be a video covering this question here in the orbital velocity and orbital period worksheet number 1. I took another look at it during B-Day today, and noticed I had a student that got what I originally figured and what I had in the key. And it didn't match up with what we figured on A-Day. So on A-Day, we figured that it was actually going to be something like 3.58 times 10 to the, I believe it was the 10th power meters. Or it may have been the 11th power, whatever it was. We refigured that and we changed the answer to that answer, the 3.58. But we looked it up again. We used Google, we used Wikipedia, we used a couple of NASA sites, and we saw that actually the orbital radius of Jupiter is actually this. It is 7.78 times 10 to the 11th meters, or 7.78 times 10 to the 8th power kilometers. Basically 778 million kilometers away is Jupiter from the sun. And so we were trying to figure out on B-Day, like, okay, how did we get these decently different numbers? How was it that we got these numbers? And here's what we figured out. Here's what we did that will be super duper valuable to you while you're working on worksheet number 2, and something to keep in mind and to use while we're working on this. So everything that we've done in the calculations, like, this is all correct. The way we set it up here is completely correct, perfectly correct. But it's when we pop it into the calculator is where there's some issues. So I'm going to put it all into the calculator in one go and show you what it is that you need to do to get the correct answer here, which in this case is the 7.78 times 10 to the 11th power for the distance between Jupiter and the sun. And before I do that, I'll just tell you, like, I'm not going to be taking points away. If you got the 3.58, I'm not, like, taking points away from you, nothing like that. It's just to show you how to set this up, because I did it wrong in class, showed it wrong, but I did it correct the first time, but I forgot the one super important thing that we've got to do in order to get the correct answer, and this is what it is. So I'm going to pop this into my calculator. Here, I'm going to zoom in on my calculator here so you can see a little bit better. So this is what we need to do. So I'm going to do this all in one go, by the way. Okay, so 3 parentheses, and I'll show you why 3 parentheses. So in this case, we have our orbital period in seconds for Jupiter is 374371200. Okay, pop that parentheses around that guy. Then we're going to divide by the 2 pi. This is where we made the mistake, including me, this is where I made the mistake. The 2 pi has to be in parentheses. Okay, the 2 pi has to be in the parentheses. For whatever reason, and I don't know why, but for whatever reason, even if I separate, like if I keep this guy in its own parentheses here, it still, for whatever reason, divides this number by the 2 first, and then multiplies by the pi, rather than 2 pi, then divide. Okay, so I don't know why. Doesn't matter if your calculator is in degrees or radians, that has nothing to do with it. For whatever reason, it just does not, you have to put parentheses around the 2 pi. And that's it, like that's all we have to do, so watch. So I'm going to then put this whole operation into parentheses, square that. Now I capped it off, so this is all self-contained now. Just this one, basically, or I should say these 4 operations, this times this, and then this divided by what that is, and then squaring this whole thing right here. So that's all cased off. And then while I'm still finding the cubed root, so my parentheses is still underneath the line here. Now I'm going to put in my big G. Then I'll just casually multiply by the mass of the sun. Oops. And then I have my operation. And so now I'm going to hit enter and show you what I get. And what I get is what we should have gotten in the first place. It should have been 7.78 times 10 to the 11th power. So when we are finding, especially for the geosynchronous problems, The thing that we were doing wrong is that we were not keeping the 2 pi in parentheses. So this will also translate to other problems, and I'm going to take a peek at my keys, the previous keys where 2 pi came up, which isn't a whole lot, but a lot of them, but it's possible that this made a difference in a number of other places in my keys. So I'm going to just advise you, if there's any time that you have 2 pi something, probably not a bad idea to just put a parentheses around the 2 pi. Okay, not a bad idea at all. Because here it is not just important; it is completely necessary. And the only way you're going to get the correct answer is putting the parentheses around the 2 pi. And just real quick before I end it, because I just don't want to go on that much longer about it. If you do this question step by step, so if you first took the 374371200 and then divided, and then you divided by the 2 pi, even if you just do it step by step like that, you still need to put the 2 pi in parentheses, because you will get 2 completely different answers if you don't put 2 pi in parentheses. So here's what I get when I put it 2 pi around the parentheses. Here's what I get if I don't. Okay, it's a significantly different number. Okay, like significantly different. So make sure, again, that we put 2 pi in parentheses. And that's the end of the video, guys. That's all I wanted to point out to you. If you still have any questions for me, make sure you get a hold of me. If not, I'll see you guys in the next one.